We here at Burdell Consulting pride ourselves in our ability to solve a wide range of difficult problems for our clients. Here at Burdell, we have a team of math consultants that are experts in graph theory, as well as a large team of programmers to put their ideas into action. Today, we will demonstrate how we can solve all of your existing problems. 10 years ago, Walmart planned out all of their stores so that they had at least one store within 15 miles of 90% of the U.S. population. Unfortunately, while their stores must always stay in one place, people can move around. Walmart now must decide where they should build new stores in order to efficiently cover the same proportion of the population as before. Our goal is to describe the location and order these new stores should be built in order to maximize profit and limit the expenditure of resources. While this problem may seem trivial, there are a host of factors to consider. The current and competitive store locations, population shifts, road coverage, and environmental factors all affect the efficiency of new store locations. For every additional factor we consider, the computational intensity of this problem increases exponentially, making current solutions very cost inefficient. Now that we understand the difficulties involved in the project, I'll give the floor to Robert, our in-house mathematician, to discuss our solution to the problem.
In our first step, we are concerned with the task of finding locations to build new stores. Now, the ultimate goal is to get residents of most of these currently uncovered population areas within 15 miles of a Walmart. One way to do this is to build a store within each of these population areas. However, this is extremely inefficient. Instead, it is better to find locations on the map that are within 12.5 miles of several population areas. This way, a store can be built at that location and several population areas become covered that were before uncovered. So the problem is now one of optimization. We want to find the smallest number of points on the map such that every population area is within 15 miles of at least one point. Using 2010 U.S. Census data, we will identify the areas of high population growth. From this set, we will define a subset such that the population areas in this subset are not within 15 miles of an existing Walmart location. Since these areas are the only things that we really care about at this point, we are going to take all of the non-essential stuff off the map and just leave the currently uncovered population areas. As an example, we have constructed a map of such population areas, and we are going to use this map to help explain our solution method. Now, the first thing that we are going to do is to split each population area up into circles. Now, we are going to do this so that each circle has a radius of 2.5 miles. Now, of course, some people are going to be included within more than one circle, and some circles might even include people that are in currently covered population areas. This does not present a problem, however. This only means that some people will be covered by more than one store. So here is what the map looks like once we have completed this step. Now, as we said, each circle has a radius of 2.5 miles. So this means that if the center of a circle is within 12.5 miles of a Walmart, then everyone living inside that circle is within 15 miles of that Walmart. So instead of representing the population areas as circles, we're just going to represent the circles as points, where the points are the centers of the circles. Using this representation, we are going to examine every single pair of points. If 2 points are less than 21 miles apart, we are going to draw a line between the 2 points. If we were to look at a set of 5 or 6 points and find that each point in this set had a line drawn to all other points in this set, we can define this as a clique. Fortunately for us, in the mathematical field of graph theory, cliques are objects that have been studied extensively. Because of this, methods for determining information about cliques are readily available, even though we might have to make some minor modifications. So now we're going to take this information and we want to apply it to the problem at hand. Our goal is to break this map down into mutually exclusive cliques so that every point is in exactly one clique. Breaking down the map like this is called partitioning the map. We want to partition the map so that we have the smallest possible number of cliques. Now, as we mentioned, for the entire country, this is a very computationally intense task and would take too long to determine exactly. However, we can determine a partition that is very close to the optimal partition. Now, to determine the number of cliques needed, we're going to use a pretty simple algorithm. To begin with, we're going to look at the map and determine which cliques have the most points in them. Then we're just going to remove these points from consideration and repeat the process until there's no points left. Unfortunately, even using a very fast computer, it would take way too long to determine the largest clique in a map like this. However, with the combined years of experience of our programmers, a modified algorithm can be created that will determine an approximation of the largest clique, if not the actual largest clique. Fortunately, finding the largest clique of our example will not require this. Clearly, we can see that the largest clique contains 4 points, which enables us to begin our algorithm. After we have run this algorithm, we're going to be left with a map, and every single point is going to be within a clique. Now remember what we said before. For every single one of these cliques, we know that we can find a point somewhere on the map such that every point within a clique is within 12.5 miles of this point. That right there is where we can build a Walmart location, because that means that every single person within this clique is within 15 miles of that Walmart location. And that's how we're going to determine where we need to build the new Walmart locations. Now that we have determined where we need to build the new stores, we are now going to determine the order in which these stores should be built. To do this, we are going to rank each new store using 2 criteria. 1, how many customers will the new store serve? And 2, how many of those customers are currently served by one of your competitors? The first stores we will recommend building will be those that serve more customers and compete with more competitor stores than any of the other new store locations. In the example area we're looking at, the store location on the left will be built first because it covers 4 customer locations and competes with a competitor store on every front.
Despite this dataset being fictitious, rest assured that this algorithm is not constrained by its scope and will maintain its computational efficiency when scaled to a larger dataset. With the upcoming release of the 2010 census data, you can be confident that our team will rapidly identify new population shifts and efficiently choose store locations that minimize expansion costs, keeping you one step ahead of your competitors. Here at Burdell's, we guarantee excellence and hope to do business with you soon.